Hey everyone, so welcome to a new video in this series Ichikai and his quest for Zen. So today we will be looking at this topic, calling microservices as simple as calling a function, gRPC. So jump right into agenda. So as always we will start with the problems. So why gRPC? Let's forget everything about gRPC first. If you Most of you must be familiar with the REST protocol. So first we will look at the problems with the REST protocol and how we define the APIs, and then we will go to the solve. So if we look at the current APIs, right, we normally develop. So the main problem, so first primary problem there is the contracts definition and auto code generation. So we want the contracts to be language agnostic, and API contracts to be language agnostic, and the code generation, the client server, everything code generation to be there. Now we have solved this problem in this build open API. So the it's a little hard there, and the these constructs are not first class citizen in the REST API. So people have developed some open source things over on top of the REST protocol, and it's being used there. But if you look at the gRPC, right, these problems were solved as the first class citizens. Then the next problem that we will look at the discovery. So from discovery, what I mean is that if you have lot of API calls in your organization, the services API contracts, and how do you call this? How do you share this API calls and the API calls and the services? So normally what we do is that we have this collection, Postman collection, and people populate their own calls, and they share this collection with one another. If they change any contract, they manually edit the body endpoint, anything, and they will again the syncing problem is there. Now obviously you can do it with a pro subscription, but sadly that is not the case in our organization. So but even if you look, right, a protocol, the protocol should be in such a way that you shouldn't have to use these tools to share the contacts and all. It should be part of your protocol. So we will see these problems, how these problems get solved by the gRPC. Then one major problem is with the REST protocol is that with REST protocol we mostly use JSON format. Now JSON is a human readable format, but most of the times your machines are interacting with each other for message passing. Why do they need a human readable format? So if I were to give you an example. Okay, so this was our JSON format, right? This how the message would be passed actually between the machines. So what would happen is that this key, name, amount, all of these things, this will be sent every time. But why does the machine needs to send this key for 10 to power 6 calls if they are happening between two services? So it can be a binary format, and we will save a lot of cost in terms of latency and the actual network cost. So these are the problems. So in this tutorial we will look mostly at the gRPC with Spring Boot. So we will be using Spring Boot along with gRPC, since a lot of our services are in Java. But do note that your services could be in any language. It could be in Golang, it could be in Node, it could be in any language, and gRPC works everywhere just fine. So let's look at the diagram. We will define one app interface library. So this will be in protobuf, and we will define all the API contracts here. So there is no language dependent code here. We just define the contracts in protobuf format, which is language agnostic. Now this library will be imported by both of these repositories, hello service and greeter client. So hello service is implementing the logic, and greeter client is another service which will call this service, and they communicate over gRPC. So note that this is the library and these two are the services. Okay, so let's look at this app interface library code first. So if we go into this gRPC interface, if you look at it, we have this in this main, we have this proto folder. So all our contracts will be in protobuf file, and let's look at one sample contract. So this is our service, hello service, and this is one method, RPC. We call RPC because it's a remote procedure call. So this is our method name, and this is our argument. The greeter is the argument, whatever you pass to the function. Note that the syntax is very similar to the function call, opposed to how do we define in REST calls, where we define get, put, post, endpoints and all, and it returns something called greetings. Now let's look at let's look at this greeter and greeting. These are some classes. So our greeter has this one field, message string name, and we provide this numbers. I think this mostly for maintaining the backward compatibility and all. So if you had even more of these calls, what will you do is that you will you could do something called integer int 32, and something called num of calls. This kind of you will do too. Okay, so similarly you can define lot of fields, and you have a flexibility of using lot of data types, classes under classes, everything that you can do in any language. So this is the greeter, and greeting will take this name and greet with a message. So that's all we have here. And if you will look at the build.gradle file, yeah, I forgot to mention one thing. So yeah, okay, it's okay. In gRPC we will take this protocol format, and we will auto generate the client interface and the client code, and we will publish it into as Java library. So I'm using this library, open source library, for it's a very good library for along with Spring Boot. If one thing to note is that if you are using with you may have a predefined Spring Boot version in your library. So do take a look at this compatibility version. So which Spring Boot version goes with which gRPC library, and which version of this library. So once we have these things in place, how do we publish this contract? How do we make this library? So we will, similar to OpenAPI, this is what we will use. So we will go to our cd gRPC interface, and we will run this command, publish to Maven local. So what it will do, it will take this protobuf files, it will generate the Java client server code, and it will publish this to our local Maven repository. You can also publish it to remote repository. We will cover this in another module. So let's look if the library has been generated or not. So ls.m2 repository, since it's a org Akshit and gRPC interface. So you can look at on our versions, we have all the files generated, the jar, the pom, and everything. So once we have defined this contract, we have published this library, we will need to use this, right? In our, if you look at the diagram again, we need to use this in our greeter service. So first let's look our hello service. So how do we do this is that if you go to a gRPC service, in our build.gradle file, you will specify this dependency or Akshit gRPC interface, and whatever version you have defined, right? Whenever you make changes to contract, if it's backward compatible, you do a minor version bump, and if it's a backward compatible contract, you will do a major version bump. And it has some other dependency of this library which I mentioned for auto generation of client and server. And let's see how now that we have the interface, we need to apply the business logic here. So we will add one class gRPC service here. With this annotation, it will know that it is a gRPC service, and we do this extends, and in this extend we say hello service gRPC implementation base. So this is our interface, and this is the entire auto generated class. If we go into this, you will see that all the methods, services, everything is generated here, and the greeter class and everything is also auto generated. So let's go back, and once we implement this method, extend this method, right, we will have the option to just override a method. So we say hello, and the body, the request, response, everything will be filled. We have to just fill it. So let's look at how the business logic here. Command set. Okay, so what we are doing is that we are taking this request, and we are sending the response over this response observer. So this is the stream where we send it. So we get this from request.getName. Remember the name field we had defined in our protobuf format. So it takes it, it forms the reply, and it's constructing the response. So response observer dot on next. So on next we are building our response. So hello world dot greeting dot new builder and message, we are setting the message. So the field that we had defined, right, the message field, if you will look at the interface format, we had defined the name as an our input field and message as our response field. So we are setting these things in our request and response, and then we mark the response observers as on completed. You may think that it's a one more line for compared to our REST service implementation, where we just return the response. But what happens is that gRPC is very powerful, not just a single request, but it can handle the streaming request and streaming response also. So suppose if you want to upload a file, you can open a connection and you can send chunk by chunk, and if you had some reply in a streaming way, you would do on next in a for loop, and then when you have to close the connection, you would do the on completed. So since we have only one response here, we'll do the on next and we'll do the on completed. So let's start, let's get our server up and running. So we will go to our gRPC server and we will run it, gradle w boot run. So if we look at it, our port, our server has started at this 1990 port. So we will look at how the API calls look. We want to see that if it's actually running or not. So how do we call this? So first let's look at the simple GUI method which everyone is comfortable with in Postman. So we will create a new collection, a gRPC request. So all we have to do here is that we will provide the host where it's getting hosted. So localhost 1990 was the port, and now we will look at the very powerful feature of gRPC, which is reflection. So we talked about this problem, right? We had this problem of discovery. We don't want to manually fill in the endpoints, we don't want to manually fill the request body and everything. So what we will do is we will tell him to use this reflection API, and see, it has found all the methods in this service. So say hello was one of our service, and check and watch were the auto generated thing. So we want to invoke this. So how do we fill the message body? We click on this generate example message. So it will look at the object structure also, and we can give our example name here. So let's say Thalaiva, and let's invoke it. So we got the response message, hey Thalaiva, what's up? So you can see it's very similar to REST interface, but we don't want to be too tied up to a GUI tool. So we will also look at what is the equivalent of a curl call. So that was one more thing in our agenda, right? We want to have a curl for gRPC. How do you call, since you use curl for our REST APIs, how do we use a curl for gRPC calls? So there is a very nice tool called gRPC CLI, and it's the equivalent of curl call. So let's look at how would we do it. So let's go to readme.md, and first what we will do, we will list all the services on this localhost 1990 port. So gRPC CLI ls. So normally how do you do ls on a directory? You will do on a service also. So when you do ls on a service, you got this service, hello service, right? So let's dig in. With ls we will do hello service. So it said that it has a method called say hello. Now for this method we want to look at how does the request response look like. So it's a -l, I guess. Okay, -l, and if you look at it, right, it's a say hello with hello greeter and greeting. So we want to look at the structure of this greeter just from a curl perspective. So how will we do this? That is that we will invoke this greeter type, we'll copy this thing, and this way we got the from the running server we are getting everything. We don't have to look at anything. So if you have these services running on some remote machine and you are some independent developer who wants to know about the services without looking at the code, this how would you do it from this from the CLI call. So it's using the reflection API basically. So this is the format of the message that you want to pass. So let's look at how will you make an actual call. So let's look at, so gRPC CLI, let's look how it looks like. So this is the gRPC, we are calling this method, this is the host name, and this is the say hello, what we got from here, this say hello part, right? If we were to do this gRPC CLI ls minus l, we will get this in this way, dot ls gRPC hello service say hello. So we will call this method. So this is our call, this is our method, and this is the request body type, this name and Thalaiva, right? Let's call this thing. So we got the response, hey message, hey Thalaiva, what's up, and RPC succeeded with okay status. So this is the gRPC CLI way. We saw the Postman way also. Now we want to call it from another service also. So we have this another gRPC client. So it has, if you will go to the build.gradle file, it has imported the same library, the protobuf library that we have published. So org Akshit gRPC interface, and let's look at the client logic, right? So what it's doing is that it's every second it's trying to call this service. So this this code has been auto generated, this hello service blocking stuff. So it's a blocking way. If you want to do it in a unblocking way, there will be another class. If you let's look at it, dot hello service async stub would be there, future stub, async stub. So you can call async way also. So this is all auto generated code. If you look at it, it's an auto generated class. And what we are doing here is that we are calling this service, and we are automatically we are able to do hello service blocking dot say hello. So it's as simple as an RPC call here, and we are building our request type hello world dot greeter dot new builder, and we set Thalaiva, and we do the build and get message. So let's run our client also. cd there's a gRPC client, that's a gradle w boot run / gradle w boot run. So our client is starting now, is importing that library, and it will start calling that server. So if you will look at this, right, received greetings, hey Thalaiva, what's up. So yes, let's summarize what have we learned here. So we looked at now, since all of this transmission was in binary format, we don't incur the cost and latency of the gRPC of the JSON format. We were able to see the discovery from the Postman, auto discovery of all the methods and the request response type from the both Postman and gRPC CLI. And we looked at the contract definition and code generation, the auto code generation and the protobuf contract generation from our common interface library. Okay, that was all for today. Hope it helps you.